All right, lesson 4-1, we're talking about bisectors of triangles. And as you're working through these questions, use these first 3 slides here that I'm showing you as a guidance as you're working. Determine, is it a right triangle? If it is, use these pictures here. If it's an obtuse triangle, use these. If it's an acute, use these. So just use this to your advantage to know, are things congruent? Do they make a right angle? Look at relationships like that and mark your pictures accordingly. Okay, so let's look at this first picture. We know that we're talking about perpendicular bisectors, so we know for sure which triangle to look at. We also are dealing with an obtuse triangle, so let's go over here and look at the obtuse triangle. We can see a couple of things here. We know that each side is cut in half. We can see that here. We know that every distance from the vertex, so I'm going to highlight these for you in purple, the distance from the vertex to that circumcenter, all of these distances are the same. And so that's a big question that you're going to be asked quite a bit. So know that the distance from where they all meet to the vertices are the same. So let's look at the question here and look at what it's asking. It says that they intersect at point G, so that's your circumcenter, and it wants to know the length of GA. Well, if we look at this picture here, the length of GA is the distance from the circumcenter to the vertex, just what we were talking about. So all of these red lines are the same. So if one of them is 11, they're all 11, which means GA is 11. Okay, the next one, angle bisector. Again, we're talking about an obtuse triangle, so let's go there for a second. We're looking at our angle bisector picture. A couple of things that we need to point out from there. We know each angle has been bisected, which means it's been cut in half. We also know the distance from the incenter to the edge of the triangle. Those are all the same. So those are the only type of questions that they're going to ask you about an angle bisector. So let's look at this one. If they say they intersect at point P, there's your incenter. They want us to find HP. Well, HP is this distance from the incenter to the edge, and we just talked about that all of those are the same. So if one of them is 15, they're all 15. All right, number 3 says N is the incenter, and so if it tells you you have an incenter, then that automatically tells you that you have angle bisectors. So I'm going to go ahead and make a note of that for you. Okay. So they're giving us the length of ND, so I'm going to highlight that. They're giving us the length of NE, and they want us to find NF. Well, we just talked about that anytime you have angle bisectors, the incenter from where the angle bisectors meet up is the incenter. The distance from that incenter to the edge of the triangle are always congruent. So we know that ND and NE are the same, so we can set up part equals part. So we can say 6x minus 2 equals 3x plus 7, and we can solve that. Move your 3x over, leaves you with 3x, add the 2 over, gives you 9, divide by 3, x equals 3. Now it's not asking for x, it's asking for NF, so we're going to take and plug it in. Well, they didn't give us an expression for NF, but they did give us the other 2, and we already said that they're all congruent, so it doesn't matter which one you plug it into. I'm going to choose to plug it into NE, so 3 times our x is 3 plus 7, so 9 plus 7 gets me 16. So we now know that NF equals 16. Okay, another incenter question, so that means I'm still talking about an angle bisector. So let's look at what was given here. They gave us something about NQ, they gave us something about NR, and they want us to find NS. Same situation. We know the distance from the incenter to the edge are all the same, so we would set this up as part equals part, and we could say 3x minus 2 equals 2x. I'm going to not solve this one all the way out because I know you can solve for x, and then plug it back in. So same situation, just knowing that the distance from the incenter to the edge of the triangle, they're all the same. Last one here, circumcenter. We know circumcenter is when all the perpendicular bisectors meet up. We can already see all those right angles. And so we have a right triangle here. So let's go to our pictures over here for a second and look at the right triangle and where the circumcenter is. Know that the circumcenter is on the hypotenuse this time. And so we know a couple of special circumstances. Again, all 3 sides have been bisected. We also know the distance from the circumcenter to the edge, or to the vertex, those are all the same. Just a couple of things to think about as you're working. So let's see what they're asking here. They gave us information about px, they gave us information about py, and they want us to find pz. Well, we already said the distance from the circumcenter to each vertex are the same. So again, we know that we can set this up as part equals part. So it doesn't matter what order you put them in, as long as you set them equal to each other, which is what you're going to do a lot with these types of questions. And then we would solve for x. Once you get x, remember to plug it in, because it's not asking for x, it's asking for pz.